We present Lumitrack, a novel tracking technology that uses a projector and one or more sensors. Each sensor is able to localize its 2D location within a field of projected light. Lumitrack provides high speed, high accuracy, and low-cost motion tracking. Like other tracking approaches, Lumitrack is based on projected structured light. However, more uniquely, our projectors emit special patterns called M sequences. These are patterns in which any consecutive subsequence of M bits is unique. In this illustrated example, the projector emits a one-dimensional M sequence. Here, we've added a sensor, shown in green. Note that only a small part of the pattern falls onto the sensor. The sensor also knows this M sequence, and because the subsequence is unique, the sensor can look up its location within the projected field. This is the basic concept behind Lumitrack, which is extended to 2D tracking with the addition of a second orthogonal M sequence. Multiple sensors can be combined to enable 4 and 6 degree of freedom tracking, which has many powerful interactive uses. Our approach can utilize digital projectors, like this laser LCOS-based Pico projector. We also created low-cost fixed image projectors by rendering our M sequences to film. We insert these film elements into a low-powered, compact LED-based projector, which costs under $10. A bidirectional sequence pattern can be created with 2 static projectors, one emitting red and the other emitting blue. In the near future, these patterns could be made invisible using infrared light. Here you can see the 2 orthogonal M sequences projected onto a Lumitrack sensor. You'll notice the sensor board contains 2 linear optical elements, one for each M sequence orientation. These are high-density arrays of 128 photodiodes each. Here, on the bottom left of the monitor, you can see the illumination data captured by horizontally aligned linear optical elements. The stripes of the M sequence appear as peaks of different widths in the signal. To the right of the raw signal is an adaptively thresholded output. This is what our embedded software uses for pattern matching. Please see the paper for full details. Lumitrack offers an extremely high tracking frame rate, often in excess of 1,000 frames per second, with low latency and sub-millimeter accuracy. To establish these performance characteristics, we conducted a series of experiments on commercial-grade CNC platforms. In this shot, we attempt to hold our hand as still as possible. The vibrations you see are the minute tremors of the muscles in our hands. If we put the projector into a clamp, you can see the position is extremely stable and accurate, to within 1/10 of a pixel. We created a series of example applications to highlight the feasibility and potential of our approach. Here, we've attached a Lumitrack sensor to the top of a spray paint can, which can be translated in front of the display. A physical button controls the flow of paint. In this demo, the user manipulates the projector, much like a laser pointer, to control an on-screen cursor. Using buttons on the projector, the user can switch between draw and erase tools. Alternatively, we can embed the projector into a sword prop, providing fluid and high-speed tracking for gaming purposes. In this example, we've embedded sensors into the grips of an airplane yoke. Using 2 sensors gives us rotation and also distance from the projector. This is used to control the pitch and yaw of a virtual plane. Lumitrack can also be used in projected augmented reality applications, such as this overhead space example. Here, we've attached 2 sensors to the front bezel of a laptop, which is running a racing game we built. The user can take control of the virtual car by translating the physical car model on the surface of the table. This allows the user to move both side to side and also forwards and backwards to help avoid traffic. With 4 sensors, we can offer rudimentary 6 degree of freedom tracking, that is, 3D position and 3D rotation. If the sensors are placed on the user, we can create experiences like this avatar head following the user's movements. Alternatively, the user can manipulate the projector, which in this example is affixed to the sleds of a helicopter model. Note how the virtual model on screen mirrors the user's movements. This is just a small subset of the applications enabled by Lumitrack. Please read our paper to learn more.